So class, on our previous discussion, we talked about fatty acids, both saturated and unsaturated fatty acids. So now class, let us continue our discussion with the types of lipids. Again class, if we will go back to our previous discussions, lipids are generally classified based on the presence or absence of fatty acids. So ang tawag natin sa mga lipids that possess a fatty acid group would be saponifiable lipids. And class, saponifiable lipids are further classified based on the presence or absence of glycerol. And for each type, we have two specific examples. Let's start class with saponifiable lipids with presence of glycerol group. So we have two examples for that. We have the triacyl glycerols as well as the glycerophospholipids. So guys, let's start with triacyl glycerols or triglycerides or TAGs for short. So class, no, what's good with the term triacyl glycerols is it already describes its structure or composition simply from the name itself. So we have triacyl glycerols, which means we have three acyl groups bound to a glycerol. Triacyl glycerol. So justify natin itong term na to. So class, tags, so let's us just call them tags for convenience. So tags class have two primary composition. So tags are mainly composed of a glycerol, which is referred to as the backbone. So later, justify natin kung bakit backbone yung tinuturing sa glycerol in some references. So we have glycerol, which is referred to as the backbone. Then we have fatty acid. So class, pansin nyo, no? Glycerol or glycerol is comprised of three alcohol groups. It has three OHS. It has three ROHS. Thus, we can say that glycerol class is a trihydric alcohol. It is a trihydric alcohol because it contains three hydroxyl groups. So class, paano nga ba na-form ang isang tag? So class, tag or triacyl glycerol formation is mainly governed by condensation reaction. So I assume you are already familiar with the condensation reaction based on our previous topic on carbohydrates. Diba class? Ang mga monosaccharides is pinaglilink or pinagko-combine via condensation reaction, in which the final result para sa carbohydrates, diba, is the formation of a glycosidic bond that binds together monosaccharide units and loss of water. Right? So, ganoon din dito, class. So, let us demonstrate. Okay. So, we have the carbonyl carbon, which is partially positive. And the alcohol oxygen, the ROH oxygen, which is electron-rich because it has two lone pairs and two bonds. Okay. So, class, yung alcohol oxygen, gagamitin niyo isa sa mga lone pairs niya para atakihin si carbonyl carbon. Once the alcohol oxygen attacks the carbonyl carbon, okay, the OH group will be displaced. Mahihiwalay yung OH group na to doon sa structure. So, lagyan natin siya here. Okay. Now, plus, nung nawala si OH sa structure ni fatty acid, the carbon was left with three bonds. Si R and then yung double bond O. Class, si carbon, para maging stable, kailangan niya ng 4 bonds. Which means, nung nawala or natanggal si OH, may naging vacant na spot. Okay, so ngayon, COR, itong part na to, okay, COR, okay, kakabit siya doon sa vacant spot na yun. So from OH, this should become OR. Okay? Pero class, bago mangyari yan, kailangan munang ma-stabilize ni alcohol oxygen yung kanyang sarili. Kasi class, di ba? Since ginamit niya yung isa sa mga lone pair niya para atakihin si carbonyl carbon, then kulang siya ng isang lone pair. Saan siya kukuha ngayon ng electrons para mabuo yung kanyang lone pair? Tapos pag-bind niya sa carbon, stabilize na ulit siya. Kukuha siya ngayon ng electrons doon sa bond niya kay hydrogen. Let's say that is OH. So may kulang siyang lone pair dito, right? So the oxygen, okay, kukunin niya yung electron sa bond nila ni hydrogen at i-convert ito or mako-convert ito into its own lone pair. So nangyayari, nawala ng bond sa pagitan ng oxygen and hydrogen. So now, this OR part, since meron na siyang dalawang lone pair, it can now connect to the carbonyl carbon na may isang vacant spot. Okay? At yung hydrogen, since nawalan siya or nanakawan siya ng electron, it will become positive. So the positively charged hydrogen will attack the hydroxyl groups or the hydroxyl group. Okay, thus forming water. HOH or H2O formally. So now class, nung nag-bind yung OR sa vacant spot ni carbonyl carbon, we now have RCOOR. We have RCOOR. Okay? Which is known as an ester. Which is an ester. Okay? So ngayong class, drawing natin yung resulting structure. Okay? So class, lagyan natin ng color para ma-recognize natin. So ito class yung glycerol group, alcohol group, and ito naman yung part ni fatty acid, right? This. So ngayon, kapag yung part na to, itong OR na to, is nag-bind doon sa vacant spot ni carbonyl carbon, ito yung lalabas. It will become like this. O, then we now have the C double bond O R. Yun yung lalabas class. Okay? So ito yung chemical reaction na involved sa formation ng triglycerides. Okay? Tapos, pansin nyo class, no? Since meron siyang tatlong ROH groups, okay, then yung chemical reaction na nangyayari dito sa OH na to is pwede rin mangyari here and pwede rin mangyari here. Which means the condensation reaction can happen 3 times given na meron tayong tatlong fatty acids or tatlong carboxylic acids. So we will just repeat the result 3 times. So another, the second, and then the third. So ito na class yung formation at ito na yung structure ng ating triacyl glycerols or tags. So aside from the formation of esters na nabanggit natin earlier, di ba? This is R, C, double bond O, O, then R. That is an ester. Okay, right? From a different point of view, we also have an acyl group. This. RC double bond O. Ang tawag natin dyan class, organic chemistry is acyl. Okay? So ito class yung basis kung bakit tinawag sila na triacyl glycerols because we have 3 acyl groups bound to a glycerol backbone. Okay? So ngayon, pansin nyo class, no? anong structure yung nag-hold sa lahat ng ating mga substituents? Diba si glycerol? It holds the whole structure. Thus, glycerol is referred to in various references as the backbone. Okay? Now class, tags are generally classified as either simple or mixed tags. Now guys, tags would be classified as simple if pare-pareho or same lang yung kanilang fatty acid. Okay? If the three fatty acids present are all the same. Arachidic, 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 chloric, 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 meristic, meristic, meristic. The same fatty acid. Okay? While class, tags naman are classified as mixed when the three fatty acids are different. We have arachidic, behemic, chloric, meristic, palmitic, steric, caprilic, lignoceric, caproic, 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 arachidic. Okay? When the three fatty acids are not the same, they are classified as mixed. Another classification is that tags can also be classified as either saturated or unsaturated. Tags can also be classified as either saturated or unsaturated. So class, when we say saturated triglycerides or tags, okay, the three fatty acids are all saturated, whether they are of the same or different fatty acid. Okay? For example, you have arachidic, meristic, chloric. Yes, they are different fatty acids, yet they are all saturated. They only possess single bonds. The hydrocarbon chain do not possess double or triple bonds, only single bonds, saturated. Okay? Or even meristic, meristic, meristic. Whether the same fatty acids or different fatty acids, as long as they are all saturated, then this is classified as a saturated tags. While if within the three now class, okay, when we say saturated, there will be presence of an unsaturated fatty acid. Okay? Within the three fatty acids, when there is a presence of even one or only one unsaturated fatty acid, as long as there is presence of double bonds in the hydrocarbon chain, then that triglyceride will be classified as unsaturated. Okay? And take note, class, that saturated triglycerides, as we all know, exist as solids in room temperature, while unsaturated triglycerides class, they exist as liquids at room temperature. Okay? Now class, pasok na rin natin yung difference between fats and oils. Okay, so class, fats, okay, fats usually exist as solids. When we say fat, it is a type of lipid that mainly exists as solid, while when the lipid exists in liquid form, then it is generally referred to as oils. Next, triglycerides are stored in fat or adipose tissue. Triglycerides are stored in fat or adipose tissue, and their primary role is similar with that of glycogen. Both glycogen and tags serve as secondary source of energy. But again, gagamitin lang ang tags at glycogen kapag si patient is napakababa or sobrang kulang na ng carbohydrate reserves. Kasi class, di ba, ang primary source of energy natin would be carbohydrates talaga. So gagamitin na lang sila as sort of backup. Okay? Next, after triglycerides would be phospholipids. So class, take note that the structure of phospholipids is very, very similar to that of triacylglycerols. Which means if phospholipids are very similar to tags when it comes to structure, then i-drawing natin yung structure dito ng triglycerides. Okay, so we have O. Okay, then acyl group, which represents the fatty acids. So class, phospholipids, as we said, is very similar to tags when it comes to structure. Their only difference is that one terminal fatty acid or yung isang dulong fatty acid is replaced by phosphate group. Yung isang dulo na fatty acid ng tags is mapapalitan ng phosphate. So this will look like this. Again, one terminal fatty acid is replaced by a phosphate group or PO4. So this will become PO4. So ito class, yung magiging structure ng mga phospholipids. At ang tawag natin class sa mismong structure na to, would be phosphatidic acid. The structure class will be called phosphatidic acid because from the name itself, it possesses fatty acids together with a phosphate group. Hence the name phosphatidic acid. So class, phosphatidic acid, it is the basic structure of phospholipids. It is also considered as the simplest phospholipids. Okay? At ito yung nagsisilbing precursor para sa iba't ibang types and examples natin ng phospholipids. Okay? Now, you may think, ano yung reason behind the negative charge? So class, the negative charge of one of the oxygens of the phosphate group in organic chemistry symbolizes that it is electron rich. One of the oxygens of the phosphate group is negatively charged, thus it is deemed to as electron rich. And since the oxygen is electron rich, okay, pwede niyang gamitin yung kanyang mga electrons para mag-bind or umattach sa another structure. Okay? The oxygen, the negatively charged oxygen, may use or may share its electrons to form a bond with a certain structure or certain compound. Okay? At ang tawag natin doon sa mga compound or structure na kadalasang nagbabind or naglilink doon sa negatively charged oxygen, we will call them head groups. We will call them head groups. Head groups. Okay? So again, the negative charge of oxygen means it can use or share its electrons to form a bond with polar structures, polar compounds that we call head groups. So head groups class here in our structure is depicted as X or R. So it will look like this. In class, okay, yung X na to or head groups na to, ito yung magde-determine kung anong klase ng phospholipid yung present. Okay? So class, for the different types and examples of phospholipids, you may observe that this part is fixed. This part will be fixed at nag-iiba lang talaga sila doon sa head groups na nakakabit doon sa isa sa mga oxygen phosphate. So ganito class yung structure ng mga phospholipids. And lastly, okay, if we will look closely, okay, if we will look closely, okay, if we will look closely, ano yung nag-carry or ano yung sumusuport doon sa buong structure? A glycerol backbone, right? Okay. Tulad ng mga tags, okay, the whole structure is also supported by a glycerol backbone. Thus, it is the reason as to why phospholipids are also referred to as glycerophospholipids. Ito class yung reason kung bakit phospholipids are also known as glycerophospholipids. Because these are lipids together with phosphate bound to a glycerol backbone. Okay? Now, class, next. As we have said on our previous discussions regarding lipids, okay, phospholipids, they mainly appear as a head together with two tails. Okay? So again, ulitin lang natin, phospholipids is mainly comprised of a polar hydrophilic phosphate head together with two non-polar hydrophobic or lipophilic fatty acids. We have one polar head and two non-polar tails. So ito class, yung part ng glycerol. Ito siya. Okay. And then next, this is the phosphate group. And then this is the head group. Yun yung R or X. Tapos ito naman yung dalawang fatty acids, whether saturated or unsaturated, basta fatty acids. Okay? Ito yung reason kung bakit doon sa part ng cell membrane sa uses of lipids, di ba? Ganito yung pagkakadrawing natin. Okay? Ito class yung explanation. Next, let us now proceed with the different examples of phospholipids or glycerophospholipids. Look closely. Okay? Here's the phosphatidic acid. Okay? Here's the phosphatidic acid. Okay? Pansin nyo class, no? Sa iba't ibang examples natin ng phospholipids, okay, the phosphatidic acid structure remains. As we have said here. Right? Ito, yung buong molecule na yan, yung buong structure na yan remains at kadalasan, nag-iiba lang sila doon sa naka-attach na head group kay oxygen. Look closely. Okay? Remains. They only differ on the head group which is attached doon sa isa sa mga oxygen ng phosphate group. Same as here, here, then here. So ito class, explanation behind the structure of phospholipids or glycerophospholipids. So let us now proceed with the examples or different types of glycerophospholipids, starting with phosphatidylcholine. So class phosphatidylcholine, this is more commonly known as lecithin. So take note class that lecithin or phosphatidylcholine serve as the most abundant phospholipid in the cell membrane. Lecithin is the most abundant phospholipid in the cell membrane. So aside from being a component of the cell membrane, lecithin is also responsible for storing choline. Because from the name itself, okay, yung head group na naka-attach sa phosphatidic acid is choline. So class choline, this is a precursor for the biosynthesis of acetylcholine, which is a known neurotransmitter that mainly governs the parasympathetic or cholinergic nervous system. Okay? And choline, precursor for the biosynthesis of acetylcholine. And also class, lecithin, siya din yung nagko-comprise or nagko-compose doon sa mga surfactant na present sa lungs. So ito mga surfactant na present sa lungs, ang function nila is pinipigilan nila yung contact between the inner surfaces ng lungs. Okay, pinipigilan nila yung contact or irritation sa mga inner surfaces ng lungs. So ngayong class, if ever na si patient is deficient or kulang sa mga surfactants na to na present sa lungs, then yan, again, deficiency of these surfactants in the lungs can cause a condition known as respiratory distress syndrome. Respiratory distress syndrome. Respiratory distress syndrome, which usually occurs sa mga infants. Next would be phosphatidylethanolamine. So from the name itself, the head group would be ethanolamine. So phosphatidylethanolamine class is more commonly known as cephalin. So cephalin class is also found on the cell membrane. And cephalin is also involved in blood clotting. Okay. And actually class, lecithin and cephalin, okay, they are both known as plasmalogens. Plasmalogens. And third, phosphatidylcholine, this is usually found on the tissues. And phosphatidylserine, present on the tissues. Next would be phosphatidylinositol. So if you have already taken or if you are taking your pharmacology class currently, you are very familiar with this. Phosphatidylinositol class, this is the precursor of what we call secondary messengers. Secondary messengers, these are chemicals that cause a cascade of signals leading to the generation of a certain effect. Okay, so it mainly involves the type 2 receptors. Type 2 receptors known as the G protein coupled receptor. So class, when a certain ligand such as drug activates the type 2 receptor or G protein coupled receptor, okay, it activates or the receptor activates the enzyme phospholipase C. Okay, phospholipase C or PLC for short. And phospholipase C naman class, it mainly governs or it mediates the conversion of phosphatidylinositol into the secondary messengers inositol triphosphate or IP3 and diacylglycerol or DAG. So this inositol triphosphate and diacylglycerol, both of them are secondary messengers that ultimately leads to effect. Okay. So specify na rin natin to. Okay? So it has something to do with the GQ type of receptor. Okay, GQ. So this will be further discussed again on your pharmacology class. But again, what we need to know is that phosphatidylinositol, it serves as precursor for the synthesis of secondary messengers that lead to a certain effect. Next would be diphosphatidyl glycerol, which is known as cardiolipin. So cardiolipin class, it maintains the mitochondrial membrane. It maintains the mitochondrial membrane. And lastly would be lysophospholipids. They're found in oxidized lipids and they promote atherosclerosis, or they increase the risk of the occurrence of atherosclerosis. So atherosclerosis class means when there are excess lipids sa bloodstream na hindi na kailangan ng mga cells, kaya nga excess. Okay? Yan. WBCs or white blood cells tend to attack these excess lipids, thus forming a plaque. And once na ma-form itong plaque, these plaques can adhere, pwede silang dumikit sa walls ng blood vessel. And once na yung mga plaques na to is mag-adhere sa walls ng blood vessels, then it will cause blockade. Imagine niyo class, no? Yung blood vessels ay parang tube. Tapos yung mga lipid plaque is magkukos ng blockade doon sa tube or doon sa blood vessels. Thus, magkakaroon ng difficulty sa circulation ng blood leading to cardiovascular diseases such as hypertension, heart failure, stroke, okay, and other diseases as well. Okay? So these are the different types and examples of phospholipids or glycerophospholipids. Next, we are now done with saponifiable lipids that contain a glycerol structure. So now let us proceed with those saponifiable lipids naman that do not possess a glycerol group or glycerol molecule. So we have two examples for this. We have the sphingolipids and the waxes. Let's start with sphingolipids. So class, from the name itself, the main difference between sphingolipids and triacyl glycerols is that ang mga tags kasi class, they are hold or they are supported by a glycerol backbone. While sa sphingolipids naman class, their backbone is primarily composed of a sphingosine group. The backbone of sphingolipids would be a sphingosine. So when we say sphingosine class, this is an 18-carbon amino alcohol. An 18-carbon amino alcohol. Okay? Now class, ano yung mga posibleng modifications or changes na pwedeng mangyari sa sphingosine backbone, thus leading to the formation of different types of sphingolipids? So class, karamihan sa mga makikita nating structure is expressed in straight chain. But in order for us to understand or in order for us to explain the structure modifications better, okay, we shall use this structure. Okay, so first, itong part na to class, itong 16 carbons na to, 16 carbon, 17, 18, the 16 carbon part together with the OH, usually, sa karamihan ng examples natin ng sphingolipids, they remain unaffected or untouched doon sa structure. Usually class, or majority of our examples of sphingolipids, unaffected or untouched yung part ng structure na to. Okay? And for most or majority of the examples of sphingolipids, changes usually occur on these parts, on the amine group and the OH group. So class, ano yung mga pwedeng baguhin or sino yung mga pwedeng mag-bind or mag-link sa mga parts na to? So class, on the NH2 part, ito yung part kung saan madalas mag-link yung mga fatty acids. Ito yung part sa NH2 part, kadalasan nagbabind yung mga fatty acids natin. Whether saturated man yan or unsaturated. So class, take note. Okay? Kung kay triacyl glycerols kanina, kapag nag-bind si fatty acid doon sa backbone, there is formation of ester, right? RCOOR. Dito naman class, when a fatty acid binds to the NH2 group of a sphingosine backbone, it leads to the formation of not ester, but rather an amide. Take note of this. When a fatty acid links to a sphingosine backbone, there is a formation of amide, not ester. Okay? And class, isa pa, ang tawag natin sa mismo structure na to, dito sa mismo structure na to, okay? Ang tawag natin sa combination ng sphingosine backbone at fatty acid would be ceramide. Okay? Ang tawag natin sa mismong structure na to, in which yung sphingosine is nag-combine with a certain type of fatty acid, ang tawag natin dito would be ceramide. Okay, ceramide. So class, okay, kung sa phospholipids, phosphatidic acid yung kanilang basic structure, yun yung simplest phospholipids at yun yung precursor ng iba't ibang types ng phospholipids, di ba? Nagbabago lang doon sa head group na nakabind sa phosphate. Dito naman sa sphingolipid, ceramide is considered as the simplest sphingolipids. It is the simplest sphingolipids. Okay? It is the basic structure of the phospholipids or the sphingolipids rather. Ito yung simplest sphingolipids that serve as the basic structure of a sphingolipid, and also ito yung nagsisilbing precursor para sa iba't ibang types natin ng sphingolipids. So ngayong class, if ceramide is the basic structure, the simplest sphingolipid, at ito yung precursor ng iba't ibang types ng sphingolipids, then yung iba't ibang types ng sphingolipids, saan sila nag-iiba or saan sila nagva-vary? So class, dito papasok si OH group. Kung dito sa NH2, fatty acid ang nagbabind dyan, dito naman sa OH group class, iba't ibang types ng polar structure or polar compounds yung pwedeng mag-bind. Yan. Okay? Katulad ng oxygen sa phosphate group ng phospholipids, ganoon din dito, yung OH part sa dulo ng sphingosine backbone, pwede yang ma-attach or malink sa iba't ibang types ng polar head groups. At itong polar head groups na to, yun yung nagva-vary sa iba't ibang types natin ng sphingolipids. Okay? So ito class explanation behind the structure of our sphingolipids. So now, pag-usapan natin, ano yung iba't ibang types ng head groups na pwedeng mag-bind sa OH ng sphingosine backbone. Okay? At ano yung magiging resulting compound or resulting structure? Okay? Let us now proceed with the examples of sphingolipids. Starting with yan, ceramide plus monosaccharides. So, basin nyo class, no, sa lahat na example natin or majority ng mga examples natin ng sphingolipids, yung ceramide part remains untouched. Okay? Yung ceramide part, yung sphingosine backbone plus fatty acid remains untouched, and again, nagbabago lang talaga sila or nag-iiba-iba doon sa head group na naka-attach. Okay? So let's start with ceramide plus Ang head group natin is monosaccharides, usually glucose or galactose. Okay? So tawag natin dito class, ceramide plus monosaccharides would be cerebroside. Cerebroside. So example of a cerebroside would be galactosyl ceramide. Galactosyl ceramide. So it serves as the major sphingolipid in the nervous system. Next, ceramide plus, ang head group naman is disaccharide, then we will call this globosides. Globosides. Next naman, ceramide together with a certain type of polysaccharide, we will call this ganglioside. Okay? So class, take note, an example of ganglioside would be GM3. So GM3 is considered as the simplest ganglioside in tissues. Okay, so ganglioside. Okay. So class, take note. Okay, all of this, monosaccharides, disaccharides, and polysaccharides, what do they have in common? Lahat sila ay carbohydrates. Okay? Thus, ang nangyayari dito is nagko-combine or pinagsasama natin si lipids together with carbohydrates. Thus, these three, cerebroside, globoside, and ganglioside, they are collectively known as glycolipids. Glycolipids, which makes sense because it is a combination of lipids together with glyco, which represents carbohydrates. Okay? And yung last example natin, class, would be ceramide, but instead of carbohydrates, ang nakakabit na head group would be phosphate plus choline. So tawag natin dito would be sphingomyelin. Sphingomyelin. So sphingomyelin class, it serves as precursor for the synthesis or production of myelin sheaths. Myelin sheaths. So again, ito yung mga bumabalot or nagsusurround sa mga nerve cells or neurons para mapabilis or mahasten yung transmission or pagdaan ng mga signals or action potentials. Okay? So we're now done with sphingolipids. And lastly, for sphingolipids would be what we call sphingolipidosis. Sphingolipidosis. So class, pagka sinabing sphingolipidosis, ito ay group ng iba't ibang types ng disorder kung saan ang similarity nila is may kulang na certain enzyme kay patient na responsible sa pag-metabolize ng mga sphingolipids. So kapag kulang si patient ng certain enzyme na yon, then may certain sphingolipid din na hindi mamimetabolize. At kapag hindi na metabolize yung sphingolipid na yon, dadami siya at mag-accumulate. So enzyme deficiency leads to accumulation of a certain type of sphingolipids. Okay? So sphingolipidosis class, it usually affects the CNS as well as the immune system, which is pretty much can be fatal, especially kapag hindi naagapan kaagad. However, unfortunately, for sphingolipidosis, there is still no cure up to this point, pero there are several methods of treatment that can be done, such as organ transplant, bone marrow transplant, gene transfer, okay, pharmacological chaperone, and so much more. Okay. Now class, what are these different types of disorders that are collectively known as sphingolipidosis? So let's start with metachromatic leukodystrophy. Metachromatic leukodystrophy. Metachromatic leukodystrophy. So there is deficiency in aryl sulfatase A, and the accumulating sphingolipid would be sulfatides. Next would be Fabry's disease. So kindly read the following enzyme deficiency and accumulating substance. Next would be Gaucher's disease. So deficient enzyme is glucocerebrosidase. Thus, the accumulating sphingolipid would be glucocerebroside. Okay. Next would be Tay-Sachs disease. Tay-Sachs disease. So the deficient enzyme would be hexosaminidase A. And the accumulating substance is GM2 ganglioside. Next would be Niemann-Pick. The Niemann-Pick disease, deficient enzymes, sphingomyelinase. Thus, from the name itself, accumulating substance or sphingolipid would be sphingomyelin. Sphingomyelin. Next would be Krabbe's disease. So deficient enzyme would be beta-galactocerebrosidase. Thus, accumulating substance would be galactocerebroside. Galactocerebroside. Okay. And lastly, we have Hurler syndrome, then Hunter syndrome. Okay. So these two sphingolipidoses differ on the deficient enzyme, yet pareho sila ng resulting sphingolipids na mag-accumulate. So they both lead to dermatan and heparan sulfate accumulation. And now lastly, for saponifiable lipids, especially for those that do not contain a glycerol group, would be waxes. So waxes is a combination of fatty acids and monohydric alcohol. So as we have said on our previous discussions, the combination of a carboxylic acid such as fatty acid together with alcohol leads to the formation of ester. The formula of RCOOR or simply RCOOR. So class, if we can see, okay, it involves an alcohol oxygen and a carbonyl carbon, which is partially positive. So class, the formation of esters mainly involve condensation reaction. Okay, condensation reaction. So we have already discussed this on our previous topic about carbohydrates and also earlier on triacyl glycerol. Okay. Nevertheless, the chemical reaction or condensation reaction between fatty acids and alcohol will form waxes and loss of water, which is again expected from a condensation reaction. We link things, we connect structures and compounds with the consequence of loss of water. Okay? So class, imagine niyo no, yung fatty acid, yung R group or alkyl group sa fatty acid. Tapos, yung R din sa alcohol, parehong long chain, yung mga hydrocarbon. So it will look like this. Okay, so di natin bibilangin kung ilang carbon, no? We will just do it for the sake of representation. So like this. C, double bond, O, okay, then O, then another R. Okay. So both of these are long chain hydrocarbons. Napakaraming carbon to carbon bonds and carbon to hydrogen bonds. Okay, thus, these long linear hydrocarbon chains that are present for both the alcohol and fatty acid makes waxes very or extensively non-polar. Okay? Napakaraming present na hydrocarbon groups or hydrocarbon chains. Thus, it makes the waxes very non-polar, very lipophilic, thus very hydrophobic or water-fearing. And yung pagiging water-fearing or hydrophobic ng mga waxes, ito yung main basis para sa kanilang mga different uses. Kasi class, waxes are primarily used due to their water repellent properties. Waxes are primarily used due to their water repellent properties. They just hate water as well as polar compounds and solvents so much kasi extensively non-polar sila eh. Extensively lipophilic sila. Napakarami nilang hydrocarbon bonds. Okay? So some of the uses of waxes would include polishes, stiffening agents. Stiffening agents mean these are substances that increase the viscosity of a preparation, especially if it is a semi-solid one. Then we have candles, base for semi-solid dosage forms and preparations such as ointments. So these are the examples of our saponifiable lipids. So in our next discussion, we will talk about the examples of non-saponifiable lipids or those lipids that do not possess or do not contain a fatty acid